Okay, welcome back yet again to some more fun-filled math. In this video, I'm going to talk about the basics behind subtraction, looking at subtracting real numbers and fractions. So of course, before we get into the meaty middle, we have to be able to start at the beginning, and that is being able to understand an additive inverse. So an additive inverse is essentially the opposite of a value, okay? Meaning if you started out positive, then the opposite would be negative. If you started out negative, then the opposite would be positive. Unofficially, or I guess you could say in elementary terms, we do simply call that the opposite sign, but algebraically and mathematically it actually is the additive inverse. And the reason for that is because if you take, say, that original value with its sign and you combine it with the opposite, or i.e. its additive inverse, well, the result that you should get is 0. Okay, the way I like to think about that is if I have one apple in my basket and I give one apple away, then I have 0 apples left. So I started with 1. My opposite would be giving 1 away, or minus 1. And if I combine those together, 1 plus negative 1 gives me 0. Okay, so that's an additive inverse. So the first thing you have to be able to recognize is how to find them. So it's just as I stated. If you look here, I have a positive 7. So its additive inverse would be the opposite sign. So that would be negative, and my value was a 7. Same with my fractions. Here my fraction is negative, so the additive inverse would be to make it positive. So this is a positive, and then your fraction was 5/8. Okay. You're going to use the idea of that additive inverse when we work on subtraction. So the first thing we got to look at is subtracting what are called just the real numbers. Okay. So here, when we're talking about subtracting, we are talking about being able to rewrite your problem using only the negative, i.e. subtraction sign between numbers. So just like when you're doing, say, adding numbers together, and we put plus signs between everything, here we're going to do that same idea, but only this time we're going to use the negative signs. Okay? Now, those same rules that we used with addition would apply with subtraction, meaning if you have two values that have the same sign, then your solution has that same common sign as well. Meaning if both values are positive, then your solution is probably positive. If both values were negative, then your solution's going to be negative. Now, if you have different signs, then your solution will share the sign of the larger value. So there you just simply have to look at which number is bigger and what sign does it have, and that's the sign that you attach to your solution or your answer. Okay. Now when we're talking about subtraction, the number line is going to come into play in a big way. In order to do subtraction, we use the rule that we are going to take your end value minus your beginning value. But when you're thinking of that number line, what you really have to remember is this. All number lines, regardless of how advanced you are in math, start with the negative infinity on the left side, travel all the way through to your positive infinity on the right, and somewhere in the middle is 0. So what that actually means is that this is going to be your positive side, or your plus side, and this is your negative side. Now, the other thing that we need to keep in mind is that when we start at 0 and we go in this positive direction, we are counting up. So 1, 2, 3, 4, etc. The negative side, we're going to do the same thing, but in this case, now we're counting towards the negative side. We still, however, start at -1, -2, -3, etc. So keeping that number line in mind is really going to help in terms of being able to see your subtraction and what you're doing. Okay. So, our first example says we're going to take -14 and subtract 2. So one way that we can look at this is, again, we can use the negative or the number line idea. So again, negative infinity to positive infinity. I'm going to put my 0 in. And then we have -14. So I'm going to kind of put my little space here and start over here at -14. And then I have -15, and then I have -16, -17, and so on. So I am starting here at -14. To subtract 2 says that I'm going to jump 2 in this direction. So this way is where my subtraction. And notice when I subtract 2, I'm going to land at -16, thus making this solution -16. Now, another way that we could have approached this, I don't necessarily recommend it, but it is out there, is we can do like we did with the addition problems. So when you add numbers, a lot of times what we do is we say add the numbers themselves together and then slap on the sign that goes with it. Well, that idea is kind of similar here. Notice both of my terms have the same sign, which means my solution will share that sign as well. So one thing I could have done is I could have taken my number 14, I could have added my 2 to it, gives me 16 as an answer, and then remembered that both of these had my negative signs, thus -16. The reason I don't recommend that method is because most of the time we forget that negative sign. So thinking of your number line or just simply doing straight subtraction would be my recommendation to you. Now, if you notice the second example, I have opposite signs. And so here I've got a +15 and a -23. 23 is the bigger number, so this tells me that my solution should be negative. Okay. So one thing that we can do with this one is, again, we could work a number line where we start up at 15 and we count down 23. Or, because one of them is negative, here's your trick. You take your bigger number, so 23, and you're going to subtract, so we're still doing old school subtraction. So we're going to subtract away 15. So again, we can't take 5 from 3, so remember this would cross out, leave us with a 1, turn this into a 13. 13 minus 5 gives me 8. And then we need to remember my solution was negative. So I need to slap that negative sign onto my answer, and so it becomes negative. So -8 is what I'm looking for. Now here I have minus a negative. And so I know in the beginning we haven't talked a lot about it yet, but if we have minus times a negative, that gives you a positive result, thus changing this problem into 16 plus 8, which would give you 24. Another way that we can do this problem would be similar to how we worked the first one, which was to add them together, and remember that you've got the sign of the bigger term. I personally think it's easier to start learning your negative rules because they have to be applied throughout math, and so we might as well start somewhere. So if it were me doing this, this is how I would attack this problem, is to remember the rule. And the rule says that any negative times a negative is going to give you a positive result. Now in this example down here, you can see that we have to work with that, because here I have minus a negative. So this right here, where I have minus a negative 2, is actually going to become a positive 2. So I have to rewrite my problem, which means I have negative 7 plus 2 plus 6. So here, what you want to do is kind of follow your order of operations. So order of operations, say first you take care of parentheses and then exponents, multiplication, division, which we already did right here, and then we have addition, subtraction. And the way the rule states is that you are going to add or subtract moving left to right. So the first thing we're going to look at is these first two terms. So I have negative 7 plus 2. So one way that I would solve this would be to say I'm going to do 7 minus 2. So 7 minus 2 is 5. My bigger number was a negative, so I need to add that negative on there, which is going to change my equation to be negative 5 plus 6. Again, I'm now going to combine this. So if I look at, say, vertical again, I have 6 minus 5 gives me 1 as an answer. My larger number was positive, means my overall result is positive, thus 1 is my answer. Now the next one I want to look at here is a fraction. And so the fraction says, again, my two signs are negative, so my solution is negative. Okay, so my solution here should give me a negative result. Now, in order to add or subtract, you need to have a common denominator. So in this case, I have a 10 and I have a 6, and I want to look at what's common between both of those. So I would start with my 10 and ask myself, does 6 go into 10 nicely? Well, that answer is no. So I want to kind of look at multiples of 6 and multiples of 10 that are the same. And one thing that I know right off the bat is that 30 comes to mind, because 6 times 5 is 30 and 10 times 3 is 30. It's a common denominator, and so therefore it works. And so here I would use 30 as that denominator. So I have to look at my first fraction. Again, how do I turn 10 into 30? I have to multiply by 3. So I'm going to go ahead and do that. And then I am subtracting this, or I guess I could say adding to a negative. And then how do I turn 6 into 30? Well, I multiply by 5, and my fraction was the negative 5 over 6. So I have to multiply both the top and the bottom on both fractions. So I have 3 times 7, which is going to give me a 21. 3 times 10 is going to be my 30, and don't forget my negative sign. And then I have 5 times 5, which is 25. 5 times 6 is 30, which is my negative sign. And so now, if you remember fraction rules, they say that you're going to add or subtract straight across the top. So this is negative 21 minus 25 all over 30. So here we can go ahead and look at it. We are going to have 25 plus 21. So here 5 and 1 gives me 6, 2 and 2 is 4. However, both my signs are negative, so I need to input that negative here. So I really have negative 46 over 30. And now you need to reduce, which means you need to make your fraction as small as possible. So here, if I'm looking at what's in common between 46 and 30, there's not going to be a lot there. However, they're both even. So I can actually divide both of them by 2, thus giving me the result, negative 23 divided by 15. And this would be what I was looking for. Now another thing that we do fairly often is we do what's called compare numbers. Comparing numbers is fairly simple. It means that we are just looking to identify which number is bigger than which, or which number was smaller than which. So you're going to be given problems potentially where you are asked to make a true statement using your signs, and the signs that we are using are the less than, the greater than, or the equal to. Well, notice on each of these examples I have expressions on either side of my blank, and so you have to simplify the expression down to really figure out which is which. So the biggest advice I can give you here is not to assume which is which, but instead to actually prove which is which. So on the left hand side, to start with, we have minus a negative. So automatically this becomes negative 4 plus 3. Now we don't know what that is, so I'm going to input my little space. And then on the other side I have plus a negative, so this is the same as thinking about negative 4 minus 3. So in this case, if you remember, again, we can do that vertical. So we've got 4 minus 3. So 4 minus 3 is 1. However, we had the negative here attached to my largest value, which means this is actually a negative 1. Now on the other side, again, I have 4 plus 3, which gives me 7. And because both of them are negative, right here, negative and negative, I have to attach my negative sign. So I have that negative 1 is something to negative 7. Well, if you think of your number line, remember the smaller the negative number, the larger it actually is. So in this case, we would put our sign opening up towards that smaller value, stating that it's actually the larger value of the two. Our second example is a little bit easier. On the left hand side I have 0 minus 6, so you can't take or change anything there, so this is just still going to be negative 6. But on the other side, notice I have minus a negative, so this actually becomes 0 plus 6. So if I go ahead and do that, anything plus 0 or anything minus 0 is going to be itself. So this is really the same as negative 6 as compared to 6. Of course, when we're talking about the difference between negative and positive values, the positive value will always be the larger value. Therefore, we open up to the positive 6. Now here I've got some fractions, so this is going to take a little bit of work. You have to find common denominators between both sides. Okay, so let's call this side A and let's call this side B. So I need to have a common denominator for side A, and I'm looking at 4 and 8. So what's common between 4 and 8 is going to be 8. So if I look at these fractions, it's the first one that has to change. How do I turn 4 into 8? Well, I simply have to multiply by 2. So this is going to be 2 times that fraction, which is negative 7 over 4. And then we have minus a negative, so this is going to be plus, and then my 3/8 gets left alone. There's my space, and I have to look at the other side. So I need a common denominator for my side B, and I've got the numbers 2 and 3. So if you look at 2 and 3, the first thing that comes to mind would be 6. So my first fraction, how do I turn 2 into 6? Well, I have to multiply the whole thing by 3. And then how do I turn 3 into 6? Well, I have to multiply the whole thing by 2. So I need to actually do my multiplication. So back on the left-hand side, 2 times 7 gives you a negative 14. 2 times 4 gives me that 8, plus my 3 over 8. 3 times 1 gives me 3. 3 times 2 gives me 6. And then my sign is negative because my fraction's negative. 2 times 7 is 14. 2 times 3 is 6. So then we can go ahead and look at it. So first things first, if we look, I have negative 14 plus 3 over 8. And then I have 3 minus 14 over 6. So in both of these cases, I'm actually going to come out with the same answer. So if you look at it here, I would have 14 minus 3, which gives me 11. Because my 14 here had a negative sign and it was bigger, my sign is negative. So this is actually negative 11 over 8. And then on the other side, I have 3 minus 14. So again, that would tell me 14 minus 3 gives me 11. My 14 is negative, therefore this is going to be negative 11 over 6. Now if we look at these, we need to know which one is bigger. So there's a couple things that we could do. First of all, you could pull out your basic calculator and you could find out what 11 divided by 8 is. And you would find out that this would be negative 1.375, and on the other side you'd have negative 1.833. The other thing that you could do is you could have done old school division. So old school division says the numerator goes inside, the denominator goes outside. How many times does 8 go into 11? Well, it goes once. Subtract my 8 and you get 3. And then the way that division would work is you would add a 0. So we'd carry our 0 down and we would put our decimal on the top. How many times does 8 go into 30? Well, it goes 3 times. So minus my 24. 30 minus 24 leaves 6. So I got to add another 0 to carry that all the way down. This becomes a 60. How many times does 8 go into 60? Well, that's 7. And so we know that 8 times 7 gives us 56. So we subtract 56 away, leaves us with a 4. Means I have to add another 0 to carry all the way down. Makes that 40. And 8 goes into 40 5 times. So notice I have the decimal 1.375, and because my fraction was negative, it means my decimal is negative. So that is how you would do it as old school math. Now if we look at these two decimals, we need to look at the fact that both of them are negative, So then we're looking to see which one's bigger and which one's smaller. So again, the smaller the negative number, the larger the value is, and so we would put our sign going this direction. Now we can also solve equations, and we're going to use kind of the same ideas, only now we're going to start giving it more of an algebraic touch than an old school vertical touch. And so here we have to determine if the given value is actually a solution to your equation. So we are being told that we have 3 minus y equals 6, and we want to check if y can equal 3. So the way we do that is we have to substitute in for y and see if both sides equal. Okay, that's the idea behind what we're doing. So this is going to become 3 minus 3, and what we're doing is we're checking to see, does this equal 6? Well, 3 minus 3 gives you 0, and in this case we already know that 0 does not equal 6. Therefore, you would say no, y equals 3 is not a solution to the equation. Okay. So we can do the same thing over on the other side. Here we have 30, and then we have plus a negative 32 is going to equal a negative 2, and this is what we're checking. So 30 plus a negative 32, again we could do our 32 minus 30 gives us 2. Because my 32 is negative, this is a negative, so we have that negative 2 equals negative 2. And this in itself is a true solution. So because this here is a true statement, that means that yes, x equals negative 32 is a solution. Now the last thing that we can do is we can apply some of these ideas to applications. And so here we want to write out your values using positive or negative signs as told by the problem itself. So first and foremost, we have that at 2 p.m. the temperature was 76 degrees Fahrenheit. By 8 p.m. the temperature was 58 degrees Fahrenheit. Find the change in temperature. So what we first need to know is that when we are looking for a change in value, that means we are looking at taking your end value and subtracting away your beginning value. And that is going to give you the change. Now, specifically, it's the act of this subtraction that gives you the change in your two values. So what do we know? Well, we know that we started at 76 degrees Fahrenheit. And we know that because 2 p.m. falls before 8 p.m. Now that means the other thing that we know is that we end at 58 degrees Fahrenheit. So to find the change in value would say that we need to take the 58 degrees Fahrenheit and we need to subtract 76 degrees Fahrenheit. So again, what do we know? Well, we know that we can do 76 minus 58. In doing so, we find out that we have 18 as a result. Again, remember, my larger number here is negative. Therefore, we would state that your temperature decreased by 18 degrees Fahrenheit. Why? Because my answer was negative 18, and the negative signifies a decrease in what we're doing. Now that should make a lot of sense, because if you look at where you started with a big number and you're ending with a very small number. So that there also shows a very downward negative trend or turn. Now, the last example we have says that Michael Jackson was born in August of 1958 and died in June of 2009. How old was Michael Jackson when he died? Now, the biggest thing you want to note is that he did not have a birthday in 2009. Why? Because his birth month was August and he died in June. So what does that actually mean? Well, it means that your starting value is going to be the year 1958. And your ending value is actually going to be the year 2008. And the reason for that is because Michael Jackson did not have a birthday in 2009. The other thing to note is that we only want his years. We don't care about the months, okay? So all we are looking at is the years. So again, we have to find a change in the value. And so again, change in the value means we're going to take that ending value. So we're going to take that your age is going to be the ending value, which was 2008. And we are going to subtract the starting value, which was 1958. When you do that, you are going to find 50 years old. Now that number is positive, which should make sense because the bigger number here is positive. Now, if you can't do this, say horizontally, again, remember you can always do it vertically. So we would have 2008 minus that 1958 and solve your vertical math. Okay? And so just for a reminder, you do 8 minus 0, or 8 minus 8 gives you 0. 0 minus 5 doesn't work. Can't borrow from a 0, so you have to borrow from the 2, makes that a 1. Turns this into a 10, which you borrow to turn into a 9. Which turns this to 10. 10 minus 5 is 5. 9 minus 9 is 0. 1 minus 1 is 0, gives you 50. Okay. So that's kind of everything that you needed to know in a nutshell about the beginnings of subtracting two numbers together, whether they are fractions or whole numbers. The rules are the same. You're going to subtract your numbers from each other. You're going to look at the sign of the bigger term, and that is going to be the sign of your solution. Unless both of your numbers share the same sign, then whatever sign they shared is the sign of your solution. So as always, if you have any questions or concerns, please make sure that you let me know. Otherwise, I'll see you next time.